Hello everyone, today we are discussing section 3-14, which is electrical charge, conservation of electrical charge, and forces between electrical charges. Electrical charge is an intrinsic property of electrons and protons, the building blocks of atoms and molecules. The electrical charge of one proton is positive 1.6 times 10 to the negative 19 coulombs, and an electron is negative 1.6 times 10 to the 19th coulombs. The magnitude of the charge on an electron or proton is denoted by this conversion here. So 1e is equal to 1.6 times 10 to the negative 19th coulombs. So something that has a charge of 10 to the negative 9th coulombs has 100 billion electrons in it. Here's a guy associated with it, not really relevant. Let's get started. So we're starting off with question 3-14, question 1. And the question asks, a particular atom has 4 more protons than electrons. The atom has a net charge of, and then here are the answer choices. And we have to remember that an atom is neutral when the number of protons equals the number of electrons. And we have to also remember that protons are positively charged and electrons are negatively charged. And as we could see just from above, the magnitude of charge on an electron or proton is equal. So therefore, having one more proton than one electron would have an electrical charge of 1.6 times 10 to the negative 19 coulombs. But disregarding the specific coulomb amount, let's consider the option choices we have. Well, if we have 4 more protons than electrons, we could say we have n plus 4 number of protons and n electrons. We can see that the difference between those two answers is that we have a plus 4 here, and we know that protons are positively charged, so we then know that there must be a positive charge on this atom. So immediately, without looking at anything else, we can disregard E, C, and A, and then denoting between B and D, we have the fact that we know that the magnitude of charge on an electron or a proton is equal, meaning that having 4 more protons than electrons would have a difference of positive 4e, and that is why B is the answer. D is not the answer because we have 4 more protons than electrons, and we know that, as I just said, the number of the charge on a proton, the magnitude of charge on a proton is equal to the magnitude of charge on an electron. So therefore, because this number is 4, we can then assume that there is positive 4e for this specific atom. So here we have question 3-14a, and it says a wool sweater and 2 balloons are electrically neutral. 2 balloons are rubbed on the wool sweater, after which each balloon has a net charge of negative 3. What is the final net charge of the sweater? So first, let's start off by analyzing what the initial condition is. So let's write an I here for the initial condition. And here's my attempt at a sweater and 2 balloons. And obviously, they're equal size. So we know that in the initial condition, each of these objects had a charge of 0. And I want to introduce an equation that's relevant for this. So we know that the net charge, Q net, is equal to the number of protons times the electric charge, minus the number of electrons times the electric charge. So we know that Q net in the initial situation is 0. And then if we're analyzing the final scenario here, the change that occurred, we know that we don't know the wool sweater, so let's just put an X. But we know that each of the balloons has a negative 3 charge. Well, how do we add? We can add these together and say that this is negative 6, because negative 3 plus negative 3 is negative 6. So we can say x plus negative 6 equals 0. So how do we solve for x? Obviously, if you've taken any level of math in high school or college, you know that you just subtract the negative 6, so subtracting negative 6 is adding by a positive, so 6 equals x. And we know that the charge on the shirt here has a positive 6 charge. And the reason we're able to solve for this is specifically because we know that the system has a net charge of 0 at the start, and we know that because no outside forces interacted with this, that the overall system must have the same overall charge regardless of the movement of the electrons in the system. So therefore, as a result, we know that whenever a negative charge is occurs in one part of the system, it must be counteracted by a positive charge by in another part of the system, as long as there are no outside interactions. Hence why D is the answer. I just wanted to reinforce here that in a closed system, like the system we have in 3-14A, where no outside forces interact with the charge on these specific items, Q net is constant. Hence why we're able to make the assumption that the initial overall charge of the system is equal to the final charge of the system. Because it is a closed system, any change in charge in one particular part of the system has to be accounted for by a change in another part of the system. So we know that the sum of these two charges is equal to the charge change on the wool sweater. Hence why we have a positive 6 charge for the sweater and 2 negative 3 charges for the balloons, because we have this constant electrical charge within this system. Moving on to 3-14C, we have identical spheres are initially charged as shown. Sphere P and Q are touched together and then separated. Then spheres Q and R are touched and then separated. Afterward, the charge on sphere R is, and then we have options, -1 nanocoulombs or net less, -0.5 nanocoulombs, 0 nanocoulombs, positive 0.5 nanocoulombs, or positive 1 or more nanocoulombs. So let's consider the equation. Let's consider each sphere touching each other as a closed system. So when these two interact, these are usually separate, but when they interact, their charges kind of equilibrate. They balance out one another. So we can say that 4 plus -2, so 4 plus -2 equals 2. So that's the overall charge of these two. So when they're touched, so this is the net charge, is a +2. So when they're touched, they must equilibrate, meaning that this +2 charge is split between the two spheres, meaning that when P and Q are touched, both P and Q get a charge of +1 for each. And that's because when we're considering this interaction here, we know that the charge is balancing out, and we know that there are no differences between these spheres. They're identical, so they must equilibrate out. So then when we're considering the interaction between Q and R, so Q and R here, we know that after the first interaction, this is no longer -2 coulombs, it's +1. So +1 plus -1 equals 0. So when these touch, they equilibrate to 0 nanocoulombs each. So that means that R is equal to 0 nanocoulombs. Hence, C is the answer. I also wanted to say that because these are metal spheres, they are, by definition, conductors. So they're conductors, which means that they allow for the free flow of electrons. So E- is electrons. So since they allow for the free flow of electrons, this charge balances out between the closed systems because the electrons are flowing essentially across a concentration gradient from high density of electrons to low density of electrons, meaning that they equilibrate with one another, causing this difference in charge to balance out and essentially become 0 overall, specifically between Q and R. After this first interaction, we get +1 for each of these spheres, and then after this second interaction, we get +0 or just 0 for the second set of spheres. So the electrons are essentially going down its concentration gradient toward an area with less electrons in order to equilibrate, because these metal spheres are conductors and allow for the free flow of electrons. This next question we have here is actually more of a chemistry question than anything else. So we have the electrochemical reaction here, and we have to kind of figure out the change in electrical charge of these two atoms within the system. So we see initially that iron has a +3 charge, as denoted here, and then that chlorine has a -1 charge, so -1 and then +3. And then this is somewhat tricky, but we can see here that chlorine no longer has a charge associated with it, so it went to 0, meaning that it went from -1 to 0, so it lost an electron, so it became more positive, which then therefore means that electron had to stay within the system and transfer somewhere else, meaning that Fe2 plus or Fe3 plus must have become Fe2 plus, hence why B is the answer. And finally, we have question 3-14D that asks, a negatively charged rod is brought near a neutral metal. What happens? So, and then we have a little picture here. How nice. We have to remember that things of like charges repel one another. So, two negative charges, two electrons, would repel one another, while positive charges and negative charges, positive and negative, so would attract toward one another. So when a negative rod is brought toward a neutral sphere, there is kind of a polarization that occurs, meaning that the electrons in the metal sphere, because you have that free flow of electrons within metals, because they're conductors, they migrate away from the negatively charged rod. Meanwhile, the positive charges get attracted toward that negatively charged rod. Hence, as a result, if we're analyzing these answer choices, we know that because the positive charges on the sphere are getting attracted toward the negative charges on the rod and vice versa, we know that there's a reciprocal attractive force between both of these objects. So analyzing the answer choices, let's break them down. The rod feels a repulsive force from the sphere, but the sphere feels no force. Well, no, we said that the sphere feels a force attracted toward the rod, so A is not the answer. The rod feels an attractive force, but the sphere feels no force. We just said that the sphere does feel a force, and we know that the rod feels an attractive force as well, so B is false. Both the rod and the sphere feel repulsive forces. Well, this would only occur if the sphere also exclusively had negative charges, but since it has positive charges that can migrate toward the negatively charged rod, C is not the answer. And then D, both the rod and the sphere feel attractive forces. That is true, and that is why D is the answer. E, nothing happens since the sphere is neutral. Well, since the sphere is neutral, that just means it has an equal number of protons and electrons. But that doesn't but because metals are conductors, they allow for the free flow of these electrons and protons, meaning that the electrons will migrate away from the negatively charged rod, allowing for these attractive forces to exist between the metal sphere and the rod. Hence why D is the answer. And that is the last question that we have for this unit. Thank you so much for watching, and have a great day.